Okay. So, what's your guess? Late opening, early closure. What's tomorrow going to be? It can't be normal because that would actually be helpful.
I think they're gonna make us have virtual school.
They're not gonna give us.
That would be my worst nightmare.
Yeah, I think
I don't know why they can't let us be out.
Yeah, we've used them for
When you're breaking.
But you know, it would have been nicer if I knew.
The whole 9 days, we'd have a whole 9, because we're not gonna school tomorrow. It's snowing tomorrow morning.
But we could have it this
So, all right, what they're gonna do is what they did like a week and a half ago. We're gonna get here, we're gonna have first period, it's gonna be normal, and you guys are gonna have the test. And then they're gonna go, oh, just kidding, every other class is 17 minutes, so what do I do with the other
I mean, that
classes?
totally makes it easier for you, because that's so you can't do your 6th period, they're imagining in your 4th and 6th.
Yeah, I would love that.
Are we the favorite?
I don't think that benefits you that much.
Well, so it doesn't. That's what she said.
It would be the worst thing possible.
Yeah.
If we have a full period tomorrow, you're getting stinking test. If we have at least 30 minutes, you're good to go.
Really?
Yeah, I do the 30-minute version tomorrow, and then the other classes get the 45-minute version.
I don't even know what version is there anymore. Like, I hope y'all had fun in the snow, but I was like, well, how do I write this test so that they can take it in 45 minutes? Or what do I throw out if
What if we just do all of the tests based on one rank? Instead of.
Okay, anyway, I'm grumpy, so the test, we'll call it the assessment that you have potentially tomorrow. What do you guys want to go over? There's things like slope fields. I can tell you right now, I do not have the patience to grade one where you have to draw the little slanty things. Those are tedious and they take too much time, so I don't have the time to let you calculate 9 different slopes and to draw little paddles and for you to panic over it. Is it -1 or is that like -1.5? I didn't mean 1.5, so, but you might have to interpret it or draw it or be like, which one of these things is not like the other, match them up.
Please pardon this interruption.
No.
Good morning, BCC. This is Ms. Rascala in the main office. 11th and 12th grade students registered to take the Avant test today. Please report to the auditorium now. Thank you and have a great day.
You need to be able to do Euler's method. Catch to Euler's method. Take note of how far you need to go and what direction. Sometimes they do negative dx. You're going from 5 down to 0 in 5 equal steps. They don't tell you the delta x. Delta x in that case is -1. Okay. What else was on this sample test? Be able to do differential equations like integrate this by separation of variables. So that one is 1 over y dy equals x over 2 dx. You move the 2 on either side, but when you integrate, don't forget to add the plus c and then do your initial value. And 1 over y integrates to natural log of absolute value of y. You need to check is when you get rid of those absolute value bars that they don't just disappear, you're checking the positive branch and the negative branch, which one gives you the thing that is your initial value. That's the one you pick and you throw the other one out. Population, the way I taught you to do these, force this to look like change in population is k over m times p parentheses m minus p, so you can identify what m is. This one you needed to memorize the population equation as well because that's the thing that we stressed a lot more in pre-calc. Number 3 here, what's the strategy? Sorry. Tabular? No. U substitution, what's the U value?
Sine.
Sine x. because it's gonna be e to the u du, and then being able to translate the bounds. Those of you who are like getting around u substitution by doing various other things, some of you noticed on the optional delta math that there was a way that they were like, you know what, we don't want you to actually integrate it. We're going to force you to change this to this particular u value that we're picking, and you needed to change the bounds and all the terms. So there are ways that I can make you do u substitution. By saying, just do the translation for it. Alex's favorite. Love these. It's kind of a wild card. So this is asking you to integrate and plug in. What kind of integration is number 5? Tabular. G. This is how you'll see these on the AP exam, if you're lucky. What kind of integration is this? Partial fractions, and you can tell by looking at the answers are all natural log of stuff. Some kind of partial fractions. And these are all just checking. There's every possible common mistake in there. So you know the factors are going to be x minus 4 and x minus 2, even if you can't factor, because look at all the answers. But you got to be careful with your negatives and do your work neatly so that you don't get them mixed up. So this is checking that you got the setup right and that you didn't make a simple mistake, and it'll get you. Love number 7. How do you do that? Voodoo. Because what's the if it's integration by parts, what's the u value?
Would it be, what's the denominator?
Isn't it log is lipid?
Isn't it log because the acronym is lipid? So natural log, and then could we do this one with tabular?
Yeah. I think.
No. Can you guys try that one? Natural log of x over x to the 5th. So do we agree it's integration by parts?
No. Yes.
Well, if it was, Annie says the u value would be natural log of x. Sorry, what do you think? Is it right? 50-50 chance that it's not. So is dv x to the fifth or 1 over x to the fifth? 1 over? Okay. So derivative of natural log is 1 over x. Integral of 1 over x to the fifth. Raise the power to x to the fourth, but remember that's down low, so it's actually -4. So raise the power, divide by the new power. All right. So u times v minus the integral of v du. And I was subtracting a negative, so I made them positive. So I gotta here raise the power again, which from -5 to -4, dividing by that -4. Yep. Okay, what do you guys want to go over? I've been sending you tons of stuff. The kinds of things, this is the chapter review for the textbook, like be able to integrate with weird stuff. The new things that we've done are slope fields. Like, can you graph them? Like, given this, and at the coordinate 0, 0, what does it look like the solution would be? Sine? Cubic? So if you were a leaf on the ocean, which way would you go? To me, it looks like a negative cubic. Because this kind of looks asymptote-like. So it doesn't look like a sine function. Yeah.
When you do that, you just like completely just like y-based evidence of where to put the line.
Yeah, okay. And I always say, they don't ask these because they're a pain to grade. They put one on last year. I showed you guys that one. So it's like right here, I'm kind of going against the grain a little bit. The kinds of things they want to make sure, like what was shown on last year's thing, they said in their grading rubric, they wanted the entire rectangle of space having a graph on it. And they made a big deal to say that you had to respect the boundaries, like they created some kind of asymptotes. Their example, they created a vertical or horizontal asymptote, and they were like, you're not allowed to cross that. So drawing them, it's usually hand wavy, okay. But that one last year was a real pain. Fiona?
Well, I have a question about the logistic differentiation.
Okay.
And the equation that's like for the population, how do you find the A that's in front
So how do you find the A? Well, in this particular case, this example, the A in this case is e to the 4.3. But population, they need to give you an initial value. Like at time 0, there were 73 animals on the island or whatever. So at time 0, the reason they need to give you time 0 is that becomes a 1. And you should be able to figure out m from their, whatever they gave you. So if N was 146, plugging that in. The population was 73 at time 0. In that case would be,
Just one day, that's probably different.
they needed to give you a coordinate. And when we used to do these more rigorously in pre-cal, we didn't give you the initial value, we gave you 2 other time points and made you calculate stuff, like system of equations. But as fancy as I've seen them do this, they'll tell you time 0's population and you go from there.
Is K also 1 in this case, or like once you pull it apart? Like what's the K value?
In this thing that I just made up,
In the original.
in the original one, the K value in this case is a 1. And the delta math examples are all a rumor spreading, a disease spreading, or I don't know if they got creative with their populations, but things like that. This was in chapter review, you asked about this one. So, should we try this one? Like, pull it apart, and it's asking you to find the exact solution? What does that mean?
N minus P, if I remember the formula correctly.
So it's asking you to find an equation for population.
Wait, hold up. Wouldn't you have to multiply 0.002 by 800? I mean, no, not 800. Yeah. To get K.
Okay, that I'm doing this without a calculator. I turned my 0.002 into 2 over 1,000. Is that fair?
Yeah.
And because I want to force this to look like the pattern that I have memorized, there's various ways to do this, but I'm going to multiply by 800 over 800, which is just 1. I'm going to distribute the top part of that inside, and I got 800 minus P. And I still had a 1 over 800, and I didn't feel like doing the multiplies. And it turns out better that I didn't, because K divided by M equals 1 over 500 times 1 over 800, just taking my stuff. What is M that we calculated?
So M is equal to 800.
800. So multiplying by 800 on both sides, what is K?
1/500.
Just a mark eraser. So Fiona, this is how you would find the A value. They had to give us this initial population. I got A is 15. M was 800 and K was 1/500. So Hadley, what's the that?
Just the end value, so
Just the max carry capacity, so 800. Sasha, when is the population, like how many whatevers these are, when are these whatevers growing fastest? How many of them would be there?
M divided by 2, so 400.
M divided by 2, so 400. When is the population increasing? For the whole solution set, yeah. Okay. So this is the one that's posted. So what do you guys want to go over? Do you need to practice Euler's method? Give it a go? No? Sasha's like, nah, I'm good with that. We have a whole 20 minutes. So what are the new topics that you need to be able, that will definitely be on the test tomorrow?
Learn how to do the integrals and the differential equations of the population and the Euler's method, and all kinds of stuff that I'm not prepared to do.
Okay. Can you guys try this one, this Euler's method with this equation?
Oh, okay, I'm prepared.
Someone, not me. Yay!
I should start.
So, okay, you're actually doing the partial for finding the particular solution. Okay. Yep. Sorry, I was trying to give you space. So 0 plus C is just C. Yes. I appreciate it. Okay, I don't know what that says. Okay. Okay. So I need to see a little more than this before going straight to an answer. So got the C values, plugging in C value. Absolute value of 3 is 3. And then he said either y is the positive of this or y is the negative of this. And how did how did that happen?
So like undoes each other.
So exponents that are added pull apart as multiply, and e to the natural log of 3, so if he says they just undo each other. And then Martin said that thing that I couldn't read, that said extraneous. We don't want the -1 because the thing that matches our initial value is the positive.
Is it like wrong if we leave it as just ln3 though, like in the exponent? Like, do you need it to be?
Okay. In a free response, it's fine.
Okay. In multiple choice, they'll never leave it.
In multiple choice, they'll
Yeah.
never leave it.
So when you find the C, you need the absolute.
Well, the absolute value of positive 3 is 3. So if it's a number and you evaluated it, you can remove the opposite. So square root of 16, if you start to call it a 4, fine, like you can do that. Anyone want to do the Euler's method for this, which was?
I would.
Yeah. Okay.
Okay, so.
You gonna
You
come up,
need to. Yeah, you.
or should I write it for you? There you go.
Okay, so.
Sorry, you're on pointer. Hold on.
A pen.
There you go.
Wait, hold up.
Is it not behaving? Oh, sorry. You would think you use the pointing part of the pen, but no, you got to use the butt.
What the hell?
Yeah, I know.
Okay. What? What?
You can still hold it like a pen, but
We
it's just.
X, Y, Z, Y, D,
And I checked.
X.
The solution method that is on the AP Classroom video is super, super similar to this. a student a few years ago said, you're not allowed to do it in the table. They said so. I'm like, well, maybe class would put it in the table. So there we go. So in the problem, it tells you the step size of 0.1, and we wanted to get the answer to 0.2. Okay, so dx is 0.1.
Yeah.
And what's the y value that we're starting with? It's off the screen. Do you remember?
3.
3. And how do we find dy dx?
So, yeah, x times y over 2, which gives us 0.
Okay.
So we multiply, and we get 0.
And what did you do to get that dy? That
I
0?
multiply dx and dy times dy over dx.
Yep.
Which gives me dy.
Okay, so what's the new y value now that we've taken a step forward in the x?
3.
3. It didn't change.
dy dx. So it's still 0.3 over 2. This is 0.15. No, it's not a negative number. 0.015.
And they can do this to you on a non-calculator test. They can ask you to understand and deal with decimals. Dun, dun, dun.
We have for our final answer, we have 3.015, everyone.
Is it an over or under approximation, or can we tell?
Well, we need to find the formula first to see if the second derivative is positive or negative.
Okay, so yeah, to find out if it's over and under approximation, you'd have to do the double derivative and find out if the double derivative is positive or negative where.
If it's at that point.
At the given initial value that we started with, at 0.3 in this case. You want to do it? Okay.
I don't want to do it.
Well, so there was a request that we do that part, so let's do it. It's been a while since we've done derivatives. Eitan, how do we do the derivative? Product rule. Oh no, and it's implicit? Ew. Gross. First times the derivative of the second plus second times the derivative of the first. Josh, where are we testing the second derivative? What coordinate? That's nice.
What?
Are you upset with the purple part where I'm doing the double derivative? Product rule? I factored the half out because it's just in my way. I'm not feeling it this morning.
No, you differentiated the x in terms of dy.
Okay. I'm doing the derivative of xy. Derivative of a product. Chris, Preston, what did I mess up?
No. That's like after.
Okay, so Amir, I'm doing the derivative of x times y. Product rule. They told me first times the derivative is second, and Annie's like, oh, gross, it's implicit. So the derivative of y with respect to x, we usually write that as dy dx. Plus y times the derivative of x with respect to x, that's dx dx, which is just 1. So then Josh told me to plug in the x value of 0 and the y value of 3, and I got a positive 3.
Okay. So it's an under approximation.
Because the concavity is concave up, because
Yeah,
the second
concave
derivative is
up,
positive, the tangent line or Euler's method stuff, which is all based on tangent lines, are below. Jasmine? Use the coordinate they gave you rather than one that is not even guaranteed to be on the function. And also, those other numbers are ugly. Either way, it should still give you the same answer, because it'd be rude if they made concavity change within these steps, but usually the initial value is nicer, cleaner to use. Just use that. Preston?
If you didn't cancel at zero when you're doing the double derivative test, we have to substitute x, y, for 2 for dy dx.
Yeah, you'd have to get that value, but you know what, you already found it.
Okay.
dy dx in this case was also zero. So, often, some of the calculations exist in your Word or in your lab reviews. Okay. Yes, and
On one of the tests, like my integration test, the second question is like
your integration test.
it's really ugly, and I don't really know how to do it.
E to the 3x
Sorry, I just thought it like
minus 10.
over 10 over 25. So I know it was like the tangent thing, but I just thought that was.
Okay, the first thing, e to this stuff is e to this stuff. Divide by the derivative of stuff. That part's not so bad. This thing, you said it, you know it's the tangent, arctangent. So arctangent is the pattern of 1 over 1 plus x squared. So I want that 25 to go away. I'm going to factor it out. When I factor 25 out, what does that become? X over 5 squared. Or x squared over 25 that you already reduced and stuff. So reducing, that's taking 5 out of the top and the bottom. This is arctan of this. And right there I've made a mistake. What am I forgetting to do? Chain rule. Divide by the derivative of the stuff inside. The derivative of x over 5 is 1/5. Dividing by 1/5 is multiplying by 5. So if you have some messy scrawl that looks a little like that, it's that you forgot chain rule.
How did you just like separate the 10 over 25 and 1 over 1 plus x squared?
Okay, well the 10 is just a constant. Is it okay for me to push that constant over the bars? Okay. And Annie said she knew she recognized that it was arctan, so she knew that she needed a 1 there. If I take 25 out of each one, like, does the stuff in purple equal the denominator in orange?
Yes, it does.
Like, if I distribute the 25 back out, I get the same thing? Okay, so now we took that 25 out front as well.
Oh, okay.
And then she jumped. She did all of that in her head and said, well, that's x over 5, the whole thing squared.
Okay.
Which now means it's in this pattern. 1 over 1 plus stuff squared. Other questions from the integration quiz? That there were like bajillions of things out.
And you want to say something when dx is negative, does that mean you're subtracting the dy from the y value?
No.
Or is it just the
It's
y value?
taken into account. Because if we say take a step backwards one, what is the change in y? dy dx going backwards. The new dx is at 0, y minus the change in y. So the direction it comes out by doing this process. Yep.
Could we do an example on partial fraction decomposition?
Sure. The one on the sample test was done for you, but your bell's gonna ring soon.
Must is cut off, so just like me.
Did it just for you.
Thanks. That's a lot.
So yes, no? I've just confused things. But do you guys agree with the word that B is 1/2 and A is negative 1/2? So I factored the half out. And that means this A is a negative 1 and this B is a positive 1. So this becomes 1/2 natural log of x minus 4 minus natural log of x minus 2. And that was not in the multiple choice options. But that one is. I think. Let's check. And if you got the sign mixed up on top of the wrong thing, the other option is also there. Okay, so, what's that, the next one?
So the purpose of limit is that they decide what to put in the US in that order.
And then the leftovers are whatever's left over becomes a DU.
And that applies to the as well.
Limit to integration by parts, they're all the same thing.
Wait, it's
So with